I want to solve for x. And if I maybe have a look here and try to get out of logs, I don't have something as straightforward as this, so I can't get out of logs straight away. So if I look for another rule, I could try and use this one, but I notice that my base numbers have to be the same, and they're not. So in order for me to maybe try and use this one, I need to make the base numbers the same. So I need to use my change of base rule. So this instruction will tell me how to change base, and I'm going to choose to change this base here to base 5. And if I follow the instructions correctly, I'll end up with log 2x plus 1 in the base 5 over log 125, and my base is 5. If I throw this into my calculator, because it's all numbers, log of 125 in the base 5, and it's a simpler number than this, or a number I'm more familiar with, I'll replace it with it. Or I might even know what log of 125 when the base is 5 is, and whether you throw it into the calculator, you know it or not, you'll end up with 3 there. I want to get rid of my fractions, so I'm going to multiply everything by 3. So this becomes 3 times the log of 2x plus 1 in the base 5. If I multiply this by 3, the 3's cancel. Log 2x plus 1 in the base 5 is equal to 3 times this, 48. So I have options from here now again. There's one option that's pretty straightforward, but I'm not sure that you'll see it. So if we go for the option that I think you might go with, I think you probably go to your log tables and try and use this rule here, that if you have something down in front, you can bring it up. Now, if you're doing the question, you might know this is probably a bit more complicated way of doing it, and if it gets too complicated, I might try a different option. So if I bring that power up here, I'll end up with log 2x plus 1 to be cubed in the base 5. I don't want to have to work that out yet. Plus log 2x plus 1 in the base 5 is equal to 48. I can use this rule again here, of where if I have addition of logs, I can multiply the two things. So 2x plus 1 to be cubed times the 2x plus 1 is 2x plus 1 to the power of 4 in the base 5. Now, this is where I think most people will try and get out of logs, and you'll end up with something quite difficult, where you'll have 5 to the power of 48 is 2x plus 1 to the power of 4. And you really don't want to have to multiply this out by itself 4 times and solve a cubic, or solve a power of 4. So bringing that power up wasn't necessarily, the easiest move. Maybe I should bring it back down. So if I brought it back down, I could now divide both sides by 4. And now I could get out of logs. 5 to the power of 12 is equal to 2x plus 1, and just solve for x there. This was getting way too complicated for me, so I chose maybe a different route. Option 2 is actually quite similar. It'll get you to this point a bit quicker though. I have 3 of this plus 1 of it, one of the exact same thing, means that I have 4 of it. So just by noticing that I have 3 of something and 1 of something means that I have 4 of that thing. And without using lots of rules in the log tables, I'm at this point already. So without bringing the logs up, the powers up and then bringing them back down, I get to this point just by noticing. So I divide by 4 as I did last time. We'll end up with the same answer. And then I get out of logs 5 to the power 12 is equal to 2x plus 1. I'm going to work this out. So 5 to the power 12 on your calculator. I'm going to subtract 1. And then I'm going to divide by 2. I'll end up with x is equal to 122070312.